Okay, welcome back students. We're doing question 8. Let's look at the grading for question 8. 10, 10 and 5. So we're going to be getting 10 marks here, 10 marks here, and 5 marks here. And of course there's a clock on the video, but let's say we want to finish this in 10 minutes. Okay, so let's get started. So I have a picture here telling a story about values for two buildings that are vertical, and there's a horizontal broken line here and the ground is horizontal between them. Okay, so it's essentially three triangles in there grouped together. Now in terms of the picture tells the whole story, so we don't have to read this, so we don't have to split our attention. So let's get straight down here to work out the size of angle C. So C and 35 degrees are complementary because they complete 90 degrees between them. So they're called and the word complementary comes from the word complete, complementary angles, C and 35 degrees. So C plus 35 equals 90. C is equal to 90, take 35 equals 55 degrees. Okay. Mary works out that the distance between the buildings is 154. Nothing new there. They're just wasting your time when you're reading it because you already know it. Use Pythagoras' theorem to work out the distance marked on the diagram. Okay, so looking at our Pythagoras' theorem, we know that the hypotenuse squared, based on this triangle, is equal to the sum of the other two sides squared. But we're not looking for the hypotenuse squared, we're looking for the hypotenuse. So if we take the square root of both sides, we're using this equation. So that's making C the subject of the formula. And let's go ahead now and use 220 and 154 in this. So it's the square root of 220 squared plus 154 squared. Use the square function here. Plus, what could go wrong? You could forget the square function. You could use a minus instead of a plus here. But not much can go wrong. Just be aware that if you're getting a leg, you're using a minus and the hypotenuse is there, but that's for another day. Okay, even though we're not asked in this question, it's a good habit to write down the exact form, the third form, and then do your shift equals to look at the digital form. I always truncate to 3 decimal places, and then I look here now for the degree of accuracy required. And it is to the nearest meter, so I draw a line here and with an arrow and I bring it up to 69 meters. Okay, use trigonometry to work out the value of Z, the height of building B, and give your answer correct to the nearest meter. So we're trying to find this. So we're going to partition this into the lower half, which we could have calculated, but we already know it, and the upper half. Now, I suppose one of the reasons they put this in is to help you bring this. The fact that this is a rectangle means that the opposite sides are 154. So in a way it's a pity they reminded us, because they could have given us a bit more of a challenge. Either way, we've no variable for this, so let's introduce a variable of little h. And then let's go back to our trigonometry page and see what formula includes an opposite angle, a side, and an adjacent, and it's this one here. Okay, the included angle for tan is the right angle, and this is what's included between these two sides. So we proceed to write this formula out, putting in all our knowns. So we're substituting in 20 degrees. You won't put 20 degree symbol in your calculator, you can't. Equals h over 154. So what are the unknowns? It's h. We want h to be the subject of the formula. Currently there's a divising factor. It's being divided by 154, so we're going to multiply up the 154. The inverse operation we want to do to both sides is times 154. So we get h, and I'm just going to what's called reflection. I'm going to reflect left and right. So the h is equal to 154 tan 20. Okay, go to our calculator with that. And we get 56.051. Okay, we look for the degree of accuracy required, give your answer to the nearest meter. So because the 220 here is rounded already, I just need to round this, which is 56, add it to 220. So say z equals 220 plus 56, say approximately, equals 276 to nearest. Or what a nice thing to say is just is an element of the natural numbers, because we've rounded to a natural number. Okay, so let's see how we're doing from the marking scheme. We'll go ahead and grade ourselves. So for the first one we got 55 degrees. We used this middle method here. For the second one we got 269 meters. And for the third one we got 276 meters. Forgot to put in M. Might be losing marks there. Let's add the M. Okay, so we get full credit for that, and it's only 5, and that's a tendency we're seeing if we look back over the years. The harder the question, the less it's worth. Isn't that great? Okay guys, see you in the next one.